All right. So, to reflect on Friday, remember we did 3 shapes: equilateral triangles, equilateral quadrilaterals, which are called squares, and then regular hexagons. Okay, those 3 shapes, when we draw in a radius and an apothem, the triangle that is created is a special right triangle. So they were either 30, 60, 90, or they were 45, 45, 90. Therefore, we got to use all of our special right triangle properties to solve them. Today, we're going to talk about all the other kinds of regular polygons that do not form special right triangles. So, for example, here, these are the 2 most common ones that you are going to see. A 5-sided shape is a pentagon, an 8-sided shape is an octagon. Remember, when we draw in a radius, which the radius goes from the center to a corner, and an apothem, which is the perpendicular line from the center to the side, we get a triangle. Let's talk about the angles that are formed by those triangles. We had a process for doing this. In order to figure out those angles, we first split our shape by however many sides there were. So drawing in all the radii. To figure out what one measure of one of those angles was, we took 360, which is one full circle, one full go around, and we divided it by however many pieces we had. So this one I would divide by 5. To get that one piece is 72 degrees. Our next step was that when we draw in the apothem, we are dividing one of those pieces in half. So for the measure of angle 2, we would take 72 and divide it by 2 to get 36 degrees. Now, really, that's the only angle that I'm really going to care about, is that central angle divided by 2. But if we do, for whatever reason, need to know what the third angle is there, we can very easily find it by doing 180 minus 90 minus that other angle we just found. In this case, it would be 54 degrees down here. But that's how we go about finding those angles. It's the same process every time. And in fact, if we have a pentagon, no matter how big or small our pentagon is, its angles should be the same numbers. So really, we only have to find them once for each different kind of shape. So let's do it here again. For my octagon, this has 8 sides. I'm going to draw in all of the different 8 pieces by the radii. So the measure of my first angle is 360 divided into 8 pieces, which is 45 degrees. And then one apothem cuts that angle in half. So 45 over 2. Now we're not going to get super nice numbers anymore. We're going to get something like 22.5. And then if it asked you, here, let me write this in. If it asked you to find angle 3, we could do that pretty easily by doing 180 minus 90 minus 22.5. We would get that the measure of angle 3 is 67.5. Again, those are going to be the same angle measurements for every octagon that we do. So if you are really good at memorizing things, you can memorize these values. Otherwise, it's the same process to find those angles. So let's start with some pentagons. Again, pentagon, it's going to be the same every single pentagon. So I can use those values that I already found, which were that this top angle right here, I found that this was 36 degrees. Really, that's the only one that I need. So I'm going to leave it as that angle. I don't need the central angle, the big central angle, and I don't need that little angle on the bottom either. I also know the apothem in this particular problem. The apothem is 6. Remember that apothem goes from the center down to the side. And now I need to find that perimeter. Before, we were using our 30-60 or our 45-45-90 triangles, but because we don't have one here, we're going to have to go to SOHCAHTOA, sine, cosine, and tangent. The base here, or the opposite little piece, let's call it x, that's the opposite. My apothem is the adjacent always, no matter what kind of shape I'm looking at, the apothem is the adjacent. So to find that opposite piece, opposite and adjacent, I'm going to use tangent. Tangent 36, that's where my angle goes, equals opposite x over adjacent, the apothem 6. Do a little bit of algebra to rewrite this. 6 times tangent 36 equals your x. And then this is what I'm going to put into my calculator. We're not going to round this number, so keep it in your calculator. Make sure your calculator is in degree mode. I'm going to type in 6 tangent 36. 6 tangent 36. Everybody got 4.359? Now, what do I actually need in my formula? I need the perimeter. So I need to figure out what one full side length is. And to get there, I'm going to multiply whatever I just got by 2. Again, I'm not rounding. I'm keeping this number in my calculator. I'm multiplying it by 2. That is one full base, 8.7. Now I need the perimeter. So I'm going to take that number, whatever I got, 2x times the number of sides. There are 5 sides here, so I'm going to take that number that I just got, still in my calculator, without rounding, and multiply it by 5. Now my perimeter is 43.59 something, 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 something. I'm still leaving it in my calculator. I have not rounded yet. But I'm going to write 43.59, and then I'm just going to do like a dot, dot, dot to show that I haven't rounded this yet. Now, my area formula. Now that I have my perimeter, I have my apothem. Area equals 1/2 the apothem times this perimeter, which should still be in my calculator. So really, I'm going to take that perimeter, I'm going to multiply it by 6, and then I'm going to divide it by 2, and I am still not rounding until the very last step. So in my calculator, times my apothem, which is 6, times 1/2, or divided by 2, same deal, 130.8. Now I can round. Everybody sees how I'm not rounding until the very end? Units squared. Let's put that in here. 130.8 units squared. Very important that we are not rounding. Any questions on that? Especially in that perimeter, because there's so many steps to find the perimeter, you don't want to round over and over and over again. Okay, let's do another one. This time, I'm given the hypotenuse, and I'm not given the apothem or that base. So that's a lot to put into my calculator. So I'm going to show you what we can and cannot round in this problem. Again, it's a pentagon, so I know that this angle is 36 degrees. I'm not changing that at all. I'm going to redraw this because I find it helpful to kind of draw this triangle a little bit bigger sometimes. If you don't want to, that's fine. But this is 36 degrees. I need my apothem, and I need this little sliver of my base. Let's start with the apothem. The apothem, remember, is the adjacent side. So if I have the hypotenuse and I'm trying to find the adjacent, I'm going to use cosine. Adjacent over hypotenuse. So 11 cosine 36 equals my apothem. Let's plug it into my calculator. 11 cosine 36. That apothem is about 8.9. If you have multiple things that you are trying to find in a problem, the apothem is the one that I say it's okay if you round that number. If you know how to use your calculator and store a value, that's even better. But if you don't know how to do that, because I haven't taught you and I don't plan on teaching you how to do that yet, that's okay. Round your apothem. I'm going to round this number to 8.9. That is the only rounding I am going to do in this problem until the very end. Everybody cool with that? Now the next step is to find the perimeter, which means I need to find that little base. I am not going to use that 8.9 I just found. Number one, because I rounded it already, so it's not an exact value. And number two, if I got that apothem wrong, I don't want to also get the perimeter wrong because I used the apothem to find it. So I'm going to go back to that hypotenuse because I know that that hypotenuse is correct. And this time I'm going to use sine opposite over hypotenuse. Notice I'm not using that 8.9 at all. So my opposite here is 11 sine 36. And again, we are not going to round this number. 11 sine 36. 6.46 is this little piece of the base. Remember, there are two of them back to back to make one full side. So I'm going to multiply that number by 2. And then to find the perimeter, I'm going to multiply it by 5 sides. So times 2 to find the base, times 5 to find the perimeter. 64.65 is my perimeter. I am still not rounding. Area equals 1/2. 8.9 was my apothem. 64.65 is my perimeter. So I'm going to take that. I'm going to multiply it by 8.9. Oops. And divide it by 2. So I got 287.7 units squared. Any questions on that? Everybody's understanding what I'm saying about the rounding? Do not round until the end if you have the option. Are we okay if I do a little skipping around? Let's take a look at number 4. Now I've got an octagon. I can count 1, 2, 3, 4, 5, 6, 7, 8 sides. I've already found the angles in an octagon, so I don't really need to do it again. But just for the sake of everybody understanding how we do this, I take 360, I divide it by 8 pieces to get 45. I divide that 45 by 2 to get 22.5. That is this angle right here. Same process every time. Now, I know one of the bases. It's 16, which means my perimeter is going to be super easy to find. I'm going to multiply that base by 8 to get me that the perimeter is 128 units. So now all I have to do is find that apothem. I'm going to take this little triangle. What you need to be careful of here, and I'm going to put in a little angry face, this part of my triangle is what? It's 8. It is not 16. Remember, you're only looking at half of that base, so please, please, please make sure that you actually cut it in half when you take that triangle out. So this is 22.5 degrees. My opposite is 8. My adjacent apothem is A. So I'm going to use tangent 22.5 equals opposite over adjacent. I'm going to do a little bit of manipulation with my algebra here to get 8 over tangent 22.5. And that's what I'm putting into my calculator. 8 divided by tangent 22.5 to get 19.3 something as my apothem. I'm not rounding it. I'm going to plug it into my formula. 1/2 19.3 something 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 times 128. So times 128 divided by 2. 1,236.1 is my area. Any questions on that one? We're going to do one more. Go to the last one. Pentagons and octagons are probably the most common shapes that you're going to see, but they are not the only kinds of shapes we're going to see. What do we call this shape here in number 6? Anybody remember? Yeah, Aubrey? I think it has 10 sides, doesn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. It does have 10. What do we call something with 10 sides? It's called a decagon. Beautiful. So with 10 sides, nothing is going to change here. I'm going to do the same exact process. Let's first figure out what this angle is. The process to find the angle is we take one full circle, divide by the number of sides to get 36, and then I'm going to cut that 36 in half with my apothem to get 18 degrees. I need the apothem, and I need the perimeter. So let's start with the apothem because I like finding the apothem. I'm going to do hypotenuse and adjacent, so that's cosine. Cosine 18 equals adjacent over hypotenuse. Remember, if we are rounding anything in this problem, it's going to be this apothem. This apothem, I'm going to round that to 19. This is the only time I'm going to round until the very end of the problem. Same thing to find the base. In order to find the perimeter, I'm going to use that same angle and the same hypotenuse. I'm not going to use that 19 that I just found. Not cosine. Opposite in hypotenuse is sine. 18 equals opposite over hypotenuse. 20 sine 18. That's one piece of my base, 6.18. To find the whole base, I need to double it. 12.36. To find the perimeter, I'm going to take that number and multiply it by my number of sides, which is 10. Times my answer. There we go. 123.6. And then I'm going to leave that in my calculator while I find this area. So area equals 23.6. 1/2, 19 times 123.6, something. There we go. My area is 1,174.3. Any questions on that?